So to summarize our synthesis options, turn on logic replication and retiming. Logic replication is designed to duplicate logic that is generating a high fan-out signal. This duplication can be done by the designer if they know the design well enough. Retiming is best done when you have already evaluated your need to pipeline and you have added those extra registers. Remember that you don't need to pipeline with Virtex-5 as much as you did with an older architecture. You should also consider turning off resource sharing. You can also turn on logic optimization. This is a good starting point. You may find that you prefer it to be used for widening deep data paths, but this will depend upon your design and if you have deep data paths. You should turn off finite state machine optimization. Synthesis tools tend to use one-handed coding too much, and this wastes registers. Synthesize your large finite state machine with each encoding style and choose the one that is fastest and smallest yourself. Also, don't over-constrain your design during synthesis. Synthesis tools tend to make the design much larger than necessary. Also, don't use slice or LUT compression switches. This tends to waste flip-flops. All of these options tend to make the design larger, but save flip-flops and give the tools more flexibility. Now, we want to reiterate that we are providing guidelines in these modules. These are not hard rules that always deliver the best performance. But we recommend that you start out by trying these techniques with Virtex-5 devices. After that, you can experiment as you see fit, but I'm betting you will only be experimenting a little bit, if at all. As I mentioned earlier, migrating designs to Virtex-5 can be a little challenging since the architecture is so different. So let's see what designs are easy to migrate. First off, designs that use the dedicated hard IP are an excellent fit. In fact, taking advantage of this IP is critical since this will improve your device utilization and design speed very quickly. This is especially true of designs that use the low-power MGT resources, that is the serial gigabit transceivers, Emacs, DSP slice resources, block RAMs, PowerPC 440 processor, and PCI resources, all dedicated. Low-power applications that use the dedicated IP are also ideal because Virtex-5 uses optimum power and the dedicated IP is very power efficient. But also low-speed designs that were not optimized for a predecessor device family, that is, not highly pipelined, would also work very well in Virtex-5. This is because the design probably has several logic levels on its timing critical path. In this case, the 6-input LUT will yield a performance improvement right off the bat. However, note that as long as you are willing to evaluate your pipelining techniques, instantiate some dedicated IP, and verify your existing coding styles, Virtex-5 should be optimum for every design. The toughest designs are those that have not gone through any conversion. They tend to also be the slowest and the most challenging to work with. This usually includes designs that have not been resynthesized and contain old netlists and cores from previous architectures and applications. The first thing I'm going to have to do in this case is to convince this customer that they are not taking enough advantage of the dedicated hardware, which means that they're wasting some of their money. And as soon as they start adding stuff to the design and changing the design, all they'll really need is some guidance. And hopefully this REL is helping to provide some guidance. Also keep in mind that designs that have not been re-optimized may struggle to meet timing requirements of Virtex-5. So what is the chance of the design being successful if it's not going to meet your timing needs? In the end, they're going to make some changes. But besides that, some designs that don't fully utilize the dedicated DSP resources as much as possible tend to be challenging. This could be because their synthesis tool did not infer all the DSP slice resources it could have, and they hoped, and in such case, they had to instantiate the components they wanted. And maybe they just didn't know to instantiate or didn't know how to instantiate those resources. And as I mentioned earlier, designs that were heavily pipelined for an older architecture and never re-optimized tend to struggle to meet timing. Well, what do these designs have in common? Yeah, they just needed to be optimized some. But in general, I find that most customers realize that every new FPGA requires some work on their part, to fully utilize all of the architectural advantages of a new product has. In this case, the 6-input LUT structure and the dedicated IP will need to be targeted especially.